So in this video, we are going to look at LabVIEW graphs, how you can create graphs of any function in LabVIEW, whether it's a mathematical function or you are creating two-dimensional graphs between different two sets of data that you are collecting in a lab setting. Let's say if you're working on a circuit and you are changing the voltage to collect the values of a current, then if you're creating a graph between voltage and current or voltage and power, then how you are going to um, enter data and calculate and then determine that plot. And then we are also going to look at if you have to create a plot using an equation, then how you are going to use, how you're going to generate the values of the equation for its input variable like x, and from that how you are going to create a graph. And we are also going to look at the for loops, because when you are calculating, when you're trying to find the values of an equation, then you use for loop, and then you use specific values of the input x variable to calculate the value of your function of x. So let's look at first the two-dimensional graphs. So let's say you have to plot y versus x, right? X is the independent variable, y is a dependent variable. Or let's say if you in the lab setting, you are changing the voltage and you are observing current or power through different components or through one component, then your voltage is going to become independent variable and your power or your current is going to become the dependent variable. So how you're going to do in LabVIEW? Let's say x is your voltage, y is your current or power. Now these values you are entering yourself. These are two arrays. So if we go back and we go ahead and put two arrays, Control C, Control V. So these are my two arrays. Let's say I call this my voltage and I call this my current. Okay. And then as we discussed in one of the videos, that to activate arrays, we have to put numeric control. And since we are entering the values, we use numeric control. If we are observing values, then of course we use numeric indicators. And then I'm going to go ahead and stretch it. And stretch it. And this is voltage, this is current, and then you're going to go ahead and enter some value of voltages. Let's say voltage was 0 volt, 1 volt, 1.5 volt, 2.3 volt, 3.2 volt, 4 volt, 4.7 volt, and 5.3, 6.5, 7, and 8. Let's say these are the voltages that you're changing, and you're observing current, which turn out to be 0 ampere or 0 milliampere, whatever you want to call it, 1.2 milliampere, 4.3 milliampere, not 43, 4.3 milliampere, let's say 5.8 milliampere, and 3.2, so let's say 6.7 milliampere, 8.9 milliampere, 10.3 milliampere, 11.2 milliampere, 12 milliampere, 13 milliampere, and 14.8 milliampere. Let's say all of these. I'm not putting milliampere because you can always put the label as the unit is in milliampere basically. Okay, so these are your voltages and current, and you have to plot voltage versus current. So to plot, there are multiple plotting options available, and the easiest plotting option is Express XY graph. So if you go to Express and you go to Graph and you go to XY graph, that's the Express XY graph as you see over here, right? You can also choose the graph from Modern, and you have express XY graph. So irrespective, you can get from anywhere. Observe, we also have XY graph. Now these two operate a little bit differently, and both of them are discussed in the LabVIEW tutorial. So let's grab the express XY graphs. Okay. So this is your voltage in volt, and this is your current in milliampere. Right? And you can change the label if you want. Current versus voltage. Okay, so this is your express XY graph. I'm gonna go ahead and move it over here. Now this is your graphing block, and this blue only comes with the express XY. It does not come with the XY. It only comes with the express XY. And observe how easy it is. You have X connected to the voltage array, Y connected to the current array. And it will create this convert to dynamic data. This block is convert to dynamic data. So basically whatever data is coming in, it's going to convert into dynamic data for the block. So it's going to create the array for the block. And that's it. Once you run it, it's going to create the Y values versus the X values, current versus voltage. And that's pretty much it, how you're going to draw, how you can plot a two-dimensional graph using the express XY graph. Okay. Oops, not this. Let's go to, okay, which is shown over here. All right, if you are just using the XY graph, not the express XY graph, right? So you don't have this blue, this dynamic converter, you only have this. And the way you do it is you use a bundle. Basically, you bundled up X and Y values. So you make pair of X and Y. So if you're using XY graph, not the express XY. Remember, anytime you use express XY, you will see this built XY graph box, and whenever you connect it, you will see these two dynamic converters. But if you're using just XY graph, as I showed you, if you go to not graph, and then you do only XY graph. If you do this, observe, this is the only thing that will appear. This thing is not going to appear, and these are not going to appear. So basically what you do, you use this bundle block, and you bundle X and Y. And then basically your plot is going to appear. And this bundle block is in programming, cluster, class, invariant, and then bundle. Okay. Okay, now for loops, we are going to use for loops specifically. For loops can be used for any programming steps that you have to repeat for a specific number of times. Then you use for loops. So while loop and for loops. While loop, remember, we used while loop to repeat some sets of instructions based on a specific condition. As long as the condition is not met, you keep running it, and as soon as the condition is met, the while loop is going to terminate. But we don't know when the condition is going to be met. Now for loops, we already know how many times you have to run something. So that is being known in advance. And that number of times is given over here with n. So if you have to run the for loop 100 times, then 100 will be connected to n. I is the iteration of for loop. So it's going to start at 0, and if you have to run it for 100 times, each time the for loop is going to run, I is going to increase by 1. So 0, 1, 2, 3, all the way up to 99. And then there is no stop or nothing, of course, because again, it's not going to stop anytime. It's only going to stop when it will run for the specific number of times that you want the for loop to run. Okay. So this is how you use for loop. So if I go back, let me open another new VI. Okay. Okay. Oh, not side by side is better. Okay. So let's say now you want to, let me go back and then let's look at some of the, what did I do with for loop over here. Okay, so very simple program. You have a for loop. By the way, let me go and show you the for loop real quick. So for loop is, remember I showed you that is in the structures and for loop right here. You're gonna make it big. This is your for loop. So this is the number of iteration. These are the total number of loop count, and this is the number of iteration. Now, in while loop, anything that is outside the while loop is not going to be repeated. Anything that is inside the while loop will be repeated. Now, for loop, anything, even if it is outside the for loop, but a wire is connected to that thing and it is going to the for loop, then the value of that number is going to be repeated that many times. Okay. um, and it's very simple. Again, you connect some value here. For example, if you go to mathematics, numeric constant, and let's say you want to run this thing, run the for loop 100 times. So you connect 100 over here, and the for loop is now going to run for 100 times, and the value of I is going to change from 0 to 99. Okay. All right, so let's look at this. We want to, again, as I said, we want to run this loop for 100 times, and we want to populate the value in an array. Each time it will run, it will populate the value and put it in an array. So this is the for loop right here. And we want to populate the value from 1 to 100 instead of 0 to 99, because I goes from 0 to 99. So all we are doing over here is we are adding 1 into the value of I, and that output, the output of the adder is going to the array. So each time it is going to run, starting with I is equal to 0, the first value that will be generated is going to be 1, second value is going to be 2 and 3, and all the way up to 100, and the array will be populated with the values of 1 to 100. Okay, as I'm not showing the output, but this is how it's going to do. Look at exercise 13. You have to use for loop to create a multiplication table, as and the front panel is shown here. So in this one, you have a numeric control to enter the value of the number for which the table has to be determined. So you have only one numeric control right here, n. And then you have 3 indicator arrays. These are 3 arrays. And I'm asking you to go from 1 to 10, right? So you have n, which will be this, times I, which is going from 1 to 10, equals n times I. So that's a product table or a multiplication table. So you have 3 arrays, which are the indicator arrays. These will be showing the values. You're not entering these values. The only value you're entering is this n. And once you run your program, then it will populate all these values for 4, for 5, for 100, 300, whatever. Okay, so this is the front panel. And you're going to use for loop for this. You're going to run the for loop for 10 times, right? You will have a user input number using numeric control. And then as user is going to enter that number, run the program, for loop is going to run for 10 times, and each time it is going to run, you're going to take the user input, you're going to multiply by, this is the iteration, you're going to multiply by the iteration, and the result is going to be generated. And you're going to capture all 3 things and put them in 3 different arrays and show the result. So that's how you're going to create the program, as simple as that. All right, so how are you going to use graphs using for loops? So it's pretty simple. How you create graphs using for loops. Let's say I'm going to go ahead and let me go ahead and just close this thing. Close. Come on, don't save. Okay. All right. So let's say you want to create a graph and populate a value of. Let me write down. This program will determine the values of let's say f of x equals 2 cosine 5x sine 6x plus 7 sine of 7x. Let's say you have to determine the value of this graph and plot the graph from, um, let's see, x equals 0 to 10. Um, x is equal to 0 to 10, and then take let's say 120 points between 0 and 10 to plot the graph. Okay. And x. Okay, so this is what we are doing. We are creating a program that will determine the value of this function fx 2 cosine 5x 6 sine 6x 7 sine 7x, and we are plotting the graph for this function from x is equal to 0 to 10, and we will take 120 points between 0 and 10 to plot the graph. Okay. All right. So what we are going to do, we are taking 120 points. So I'm going to go ahead and change this to 120, since we have to take 120 points. All right, what we are going to do is we are going to put an array, two arrays actually. I'm going to put one array in which values of x will be populated, and I'm going to put another array in which f of x values will be populated. Okay, so this is x and this is f of x. Okay. And then I'm going to insert the numeric indicator because I'm not entering any values. I'm just populating these values. I'm going to calculate the values. I'm going to calculate the values from the for loop, and I'm just going to populate all the values. So I'm putting numeric indicators instead of numeric controls. Okay. I'm going to go ahead and put an xy graph, express xy graph, since we have discussed this. So I'm going to put an express xy graph. And let's put it over here somewhere. Okay. And these are my arrays. So I'm going to put the arrays over here, x, and this is my f of x. So these two arrays. All right. So now we have to create the logic for this, right? So what I'm going to do, I'm just going to use, instead of using individual blocks, I'm just going to use express. I'm just going to use the, oops, come on, the formula block. Right? It's easy to use formula block, otherwise you will have to write the whole function with different blocks. So I'm going to write this function 2 times cosine 5x, and remember, anytime you're using cosine and sine in LabVIEW, the argument is always in radians, and since your x is 0 to 10, that's radian. In general, if it is not given to you that your input is degrees, you will always assume in engineering that your argument of the trigonometric functions is in radians. Sine 7 times x. All right, so the function is good to go. This is green, right? So I'm going to do this. Okay, so now this is running from 120. What we have to do is we have to change this into the range of x from 0 to 10 such that it is divided, the interval is divided into 120 points. So how are we going to do that? So we know that I will go from 0 to 119, right? 0 to 119. So when it is 0, x will be 0. When it is 119, x has to be 10, right? So if I do, let's see, let's go to multiplication block. If I do your iteration and then I multiply this value, which is going from 0 to 119, I multiply this value by, let's see, 10 divided by 119. If I multiply this value by 10 divided by 119, then the value when iteration will be 0, then the output will be 0. When iteration is going to be 119, the output will be 10. And then in between, your values, your whole range is going to be divided into 120 points, right? So I'm going to go ahead, I'm going to use math, numeric, and I'm going to use a multiplier block. I'm going to put iteration, and then I'm going to go ahead and go to math, numeric, and I'm going to get numeric constant. I'm going to get another numeric constant. And I'm going to get a division block. Divide. Okay. And I'm going to give this 119. And I'm going to give this 10. Okay. All right. So there's a little bit of logic that you have to create. Very simple. Oh, I did not connect 10. Very simple, based on how many times loop is running and what are the values through which loop is going through. So it's going from 0 to 119. And what values do you need? So we need the values of x to be 0 to 10. That means when iteration number 0, at iteration number 0, x should be 0. And at iteration number 119, x should be 10. So very simple, 10 divided by 119 times the iteration number. So when the iteration number will be 0, the result will be 0. When iteration number will be 119, then 119 and 119 will be cancelled out, and 10 will be left, and that will be x. So I'm going to go ahead and put this x over here. And this x is also be connected to the x array. So I'm also going to connect this x to the x array right here. Okay. And since we have result, which is calculated through the formula that we have put in there, I'm going to put this in f of x. So every time result is going to be updated, it's going to populate the value in fx. And also this x is my x, and this y is my result. There you go. Okay. So this is my control systems to create a graph, to evaluate for this equation, populate the values for x is equal to 0 to 10 and fx corresponding fx values, and then create a graph between that. So if I run this, observe, this is my graph. These are my x values going from 0 all the way up to the last value. And if I want to see the last value, let's say if I go to 190, then oops, not 190, sorry, 119, or I just go to 110. So it's going to show me the last few values. So this is my 110, which is basically 111th value 112th value, 113th value, 14th, 15th, 16th, 17th, 18th, 19th, and 120th value. Remember the, the index for the row starts from 0. So it is going from 0 all the way up to 10. Go back to the first one, 0. So it's going to show you the first value. And likewise, you can see all the values here. And this is your graph right here. Okay. So this is how you can create a single graph between x and f of x. You can extend this. Now there is also cursor that you can activate, and you can move along the cursor to find the value. So let's say, actually, you know what? First, let me show you how you can do multiple plots on the same. So let's say there is another function that you want to plot. There is another function that you want to plot, and let me go ahead and put another array. And you want to plot both functions on the same, you want to plot both functions in the same window, basically. So you're going to go ahead and numeric indicator. Okay. So I'm going to change this. I'm going to call it f1x, f1x, and then I'm going to call it f2x, f2 of x. And for the same x values, let's say you want to plot. I'm going to expand this so that I can add another. How to expand? Let me move this. Okay. Okay, I will be able to put another block over here. All right. So let's say I want to do, the program will determine the values of f1x is equal to this, and f2x equals 9 sine of 9x plus 4 cosine of 6x. Okay, so let's say I have another function f2 of x, and I'm doing the same plot. I'm using the same values of x to do the plot of that as well. I'm going to populate the values of that function in this array. So let me go ahead and put another formula block. I'm going to express arithmetic formula block and write the formula down. X 9 sine 9x, 9 times sine 9 times x plus, oh, that's plus not equal, so I'm going to change it, plus 4 times cosine 6 of x. Okay, formula is valid, so I'm going to go ahead and change this to plus. You want to populate that as well, and you want to plot that as well. So I'm going to go ahead and use the same x. Where is my x? This is my x, so I'm just going to connect it. Grab this, connect it. Connect, okay. And then my result is going to go in here, but since you have only one, how are you going to do that? That's the question, right? So what we are going to do, we are, if you go back here and look at the discussion over here, you need these blocks, build array blocks, and you're going to build array between the x values, and you're going to build array between the y values if you're using multiple graphs in the same window. Okay, so you're going to build for the y values and build for the x. So what this one is going to do is going to take the first array of x and plot it against the first array of y, and then it's going to do the second array of x and plot it against the second array of y. So we're going to go ahead and we are going to do that. Let's delete this. Let's delete this. Okay. Okay. And let's go. Don't have much room. I'm going to move it. And I'm going to go ahead and grab that build array. And where it is, I believe it's in arrays and build array right here. So I'm going to go ahead and put one build array and then another build array. Control C, Control V, build array. Observe that by default build array has only one input. And since you need two inputs, first build array for x values and the second for y, I'm going to expand this and the number of inputs will increase. So in the first build array, I'm going to put x, and since x for both the functions are same, so I'm just going to connect the same x to both of them. So where the x are going, this is my x right here, right? And this was, let's see, okay, this was x, I think. Let me delete this right here. And what was this? That was f1 of x, I believe. Okay. So I deleted that x. So what I'm going to do, I'm going to take this and I'm going to put it on x. Okay. All right. And I'm going to put f2 here because f2 is coming from this. And then since x is same, I'm just going to connect it to the second one. All right, the second build array block is for y. So the first x, for the first x, I'm going to connect the first output of y. So this right here. And for the second y, for the second input, I'm going to connect the second result. So this result is going to go in the second arrays. So the values will be populated here. And the result is also connected to the build array. So once again, if you have multiple functions to plot in the same window, in the express xy graph, first you are going to pull build array block. The first build array block will have all the x values, and the second build array block will have all the y values, right? And then the output of the first build array, which is x, will go to the x. And oops, let's do this. First, you have to delete this actually. Okay. So this is going to go to x, and then it's going to convert it, and this is going to go to y. There you go. And now when you run it, so observe now you have two functions. The red function is f2 of x, and the white function is f1 of x. How do you know which graph is what? This plot, it shows you the color of the graph, the plot 0, and if you pull it up, you will have plot 1. And you know that the plot 0 is f1 of x, and plot 1, which is red color, is f2 of x. Okay. So this is how you're going to do multiple graph, multiple plots. This is how you're going to populate the values of those functions for a specific x range divided into specific numbers. And this is how you're going to create a system like that. So the last thing that I want to show you is how you can use cursors. So to use cursors, go to the properties of the graph, and then go to cursors, and then add cursors. Cursor 0, the cursor color will be yellow. Now here it is free dragging or single point. Free dragging means that you can drag the x and y of cursor freely anywhere. I will advise you to have single points so that it will move along the graph. So whichever graph you choose, either the F1 or F2, it will move along the graph. So once you do single point, choose which one you want to move it along. I'm just going to choose F1 for cursor 0. And then I'm going to add one more, cursor 1. I'm going to change the color of this cursor to some other color, let's say green. And again, I'm going to do single point, and I'm going to do F2 of x. Okay, so cursor 0, and let's change the name of that as well. This F2 of x cursor, and then cursor 0 is for F1 of x. And both I'm going to do, the dragging type is single plot, so they're going to move along the plot when you move the cursor. And one I chose, the yellow one I chose for F1 of x to move along F1 of x, which is cursor 0, and the other one I chose for F2 of x. Okay, and then you also have to enable the cursor window. So if you go to visible item, you have the cursor legend. So make sure you enable that. So the cursor legend is going to appear right here. Yeah, you can move it around. This button is to move it around, and you can expand this. Okay. Now this cursor, remember, is going to move through the points that you have calculated, populated. Right? Now one cursor is green, one is yellow, and you can go to the left side and then pull that cursor yellow right here, and it is moving along the white function, which is F1 of x, and it is showing you the corresponding values of x and y. And the other cursor, which is green, you can go and do the same thing. Grab it with the left mouse button and then start moving it. Now it is moving along the red graph, which is F2 of x, and showing you the corresponding value wherever the intersection of the cursor is, showing you the corresponding value of x and y. So the time, if x is time, let's say, and y is the amplitude, or x, f1x and f2x, they're the amplitude, then basically it's showing you the value of time versus the amplitude. And again, these values are the same that you have populated. Of course, it's not going to go to any value that you have not populated. But this is how you're going to use the cursor. You can use these buttons to move the cursors. If you don't want to grab it and move it, then you can use this button as well. Right, right now, since you are doing only both of them started doing, because you selected both of them. You unselect one of them, then only one will start moving. Okay. The top and bottom are not going to work. They will work if it is in free dragging mode. Right now it is single point mode. Okay. So this is a detailed example that actually shows you how to plot multiple graphs in one window, how to use cursors, how to use for loops to calculate the values of an equation between a range which is divided into a specific number of points. So this is a really good example. I covered a lot of things in this example. So do some, all of these examples that I'm giving you in the tutorial, make sure you go over those examples. Don't just read them. Do those examples in LabVIEW. It will be a very good practice. For example, in this one, I'm asking you to do what? Let's see, multiple graphs. You are creating graphs of y1 2 sine t, y2 cosine t. So these two functions you are using, and the time is going from 0 to 4 pi, and you have to do 100 points distribution. So basically, the same way I told you, we are running it for 100 times, 100 points, and then I'm dividing 4 pi over 99 and multiplying it by the iteration value, right? Like the same way I did over there. And then here, I'm not using formula block, I'm just using sine block and cosine block because it's easier, it's a single function. So I just using this, using build array and doing this. And this is your graph. Discussion of cursors, as I already showed you. Exercise 15, plot the same function y1 and y2, that is these two functions, the one I'm discussing here, using the xy graph, not express xy graph. Okay, so don't use express xy graph. So don't use the graph. such that you have this blue block and these two. Once you connect it, they will appear. But don't use the graph that has this blue thing. Use the one that only has, this XY graph, as I showed you earlier. All right, so instead of using express XY graph, just use XY graph and place two cursors, one for each function, measure the output for y1 at 2 seconds, y2 at 3 seconds. Also use three arrays to display the generated values of x, y1 and y2, like I did over here. So basically you have to do the same thing, three arrays, value of x, value of y1, value of y2. Hence your control panel should have three arrays to display the generated values, numeric indicators, one graph, and one cursor screen. And these are some hints. You will have to use bundle block, as I showed you, bundle block. Actually, no, bundle block I showed you earlier when I was discussing single graphs. So right here, this bundle block, right? When you're using the XY graph, instead of express XY, you have to use bundle block to bundle X and Y. So since you're using XY graph, you're going to use the bundle, and it gives you the hint. You will have to use bundle block to make pairs of XY1 followed by build array block. So you're going to use the bundle block, two bundle blocks. First bundle block will have XY1, second bundle block will have XY2, and then you will have a build array block. The output of the first bundle is going to go to one of the inputs of the build array. The output of the second bundle is going to go to one of the arrays of build array. And then it is going to go into the XY graph, which will have only one input. Because it's not express XY, remember, it's XY graph. Right click on the graph window, go to data operations and choose make current values default to keep your graph intact once you close your file, like we discussed for matrices, right? So once you go right click on the keep current value default, then your graph will be intact. And why you want to keep your graph intact? Because I'm asking you to observe the values at a specific data point, 2 seconds and 3 seconds. So if you don't perform this, then basically once I open your file, everything will be gone. But if you perform this, then these values at 2 seconds and 3 seconds will be intact. And again, use properties and choose single point for each cursor and under allow dragging to move your cursor along the graph. Okay. All right, the last thing in LabVIEW is waveform graphs. I'm not going to go over waveform graph. It's pretty straightforward. Just read through the tutorial and use the waveform graph functions, and you will see how it is going to work. Waveform graphs, waveform chart. An example is given over here, which is pretty self-explanatory example. This explains everything. So go over this, and I'm pretty sure you will be able to understand everything. Just play with it, and it's pretty straightforward.